Now, I'd like to introduce our moderator for our opening keynote session, Dr. Ezenine Uzoh-Okoro. Dr. Ezenine is the Assistant Director for Space Policy at the White House Office of Science and Technology Policy. With almost 2 decades of government experience in both NASA, mission, and policy, Dr. Ezenine Uzoh-Okoro leads the White House Office of Science and Technology Policy Space and Aeronautics portfolios. Her policy work includes Earth observations, orbital debris, microgravity research in low Earth orbit, space weather, in-space servicing, assembly and manufacturing, aeronautics, and space science, and there's more. She's earned an undergraduate degree in computer science from Rensselaer Polytechnic Institute and, get a load of this, 3 master's degrees in aerospace systems, space robotics, and public policy from Johns Hopkins University, MIT, and Harvard, respectively. She also earned a doctorate degree in aeronautics and astronautics from MIT. She has earned several NASA awards and the 2023 Commercial Space Federation Commercial Space Policy Award. Her story is profiled in President George W. Bush's book, Out of Many, One. Please join me in welcoming Dr. Ezenine Uzoh-Okoro and her guests to the stage.
Thank you for that wonderful introduction, and good day to you all. It's an honor to be here at the ISS-DC and take part in the first of many meaningful conversations about the great work taking place on the International Space Station. So this week, we will hear highlights about the kinds of research taking place on the station. And first, we will talk about existing projects and how space is making all kinds of research possible. We're also going to zero in on space-based research that is addressing diseases such as cancer through the International Space Station National Lab. Now, if my guests will humor me for just a moment before introducing them, I'd like to set the stage for this special conversation. And in 2016, then Vice President Biden launched the Cancer Moonshot to accelerate the progress of, against cancer. And in 2022, the president reignited the Cancer Moonshot to mobilize a national effort to end cancer as we know it, working to prevent more than 4 million cancer deaths by 2047 and improve the experience of people touched by cancer. So while cancer remains the second leading cause of death in the United States, significant progress has been made through this effort, and more needs to be done to ensure that a diagnosis isn't a death sentence, and we can prevent cancer before it starts, and we can catch it early, and patients and their families are supported in navigating their cancer journey. So space-based research is a new advanced tool in accelerating progress against cancer and other human diseases. And NASA and the ISS National Laboratory are working to improve cancer outcomes. In fact, we have a message to share with you from NASA Administrator Bill Nelson.
Hey, everybody. Thanks for inviting me to say a word. The International Space Station is a one-of-a-kind microgravity laboratory where we can carry out experiments that otherwise you can't do in a one-gravity environment on the face of the Earth. And what we learn at the ISS will prepare us for long-duration stays on the Moon and eventually to go all the way to Mars. Throughout this conference, you're going to hear about research that's already taken place and how you apply that research here on Earth. Since 2011, the ISS National Lab has sponsored research that has had a big impact. Drug therapies, better hurricane tracking, new implantable medical devices. And as we transition to commercial space stations and continue to explore deep space, NASA and the Space Station National Lab are going to continue to push the edge of the envelope of science and technology. And one of those areas is cancer research. You're going to hear about new research opportunities, igniting innovation. It's going to provide researchers in government and industry with a unique opportunity to join forces, health challenges, including the cancer moonshot that is so important to President Biden because of what he's gone through in his life with his family. So I want to thank you for all you do, for all your work. And now I want to turn it over to Mike Roberts, the Chief Scientist of the ISS National Laboratory, and Lisa Carnell, the Director of NASA's Biological and Physical Sciences Division. Take it away.
So many thanks to Administrator Nelson for highlighting the importance of this effort and the role that space research can play in improving disease prevention, diagnosis, and treatment. And now I'd like to introduce our guests here to tell us a bit more about disease research in their organizations. First, I have Dr. Michael Roberts, the Chief Scientific Officer at the ISS National Lab. Mike works at the Center for the Advancement of Science in Space, CASIS, the organization that manages the ISS National Laboratory in partnership with NASA. CASIS is responsible to the nation for enabling access to the station for research, technology development, STEM education, and commercial innovation in space as a public service to foster a scalable and sustainable low Earth orbit economy. Also joining us this morning is Dr. Lisa Carnell. Lisa was recently named the Director for the Biological and Physical Sciences Division, known as BPS, at NASA headquarters. Prior to that, Lisa served as BPS's Program Scientist for Translational Research, where she led the division's strategic partnership initiatives with other government agencies, including the National Institutes for Health, BARDA, the FDA, DARPA, NSF, and the USCA. She was also responsible for advancing the division's commercial engagement initiatives. And Dr. Carnell formerly served as the Space Radiation Medical Countermeasure Lead for NASA's Human Research Program. In this role, she was involved in all aspects of understanding and mitigation of radiation-induced health effects on humans, including cancer, cardiovascular, central nervous system, and acute radiation syndrome. Welcome to you both. So Mike, let's start with you. For over a decade now, the ISS National Lab has sponsored hundreds of research projects, many of them designed to address human disease states. Now, how does the National Lab help a principal investigator with this kind of research?
Thank you, Esene. Let me begin first by expressing my sincere gratitude for being able to join you on stage today and joining Lisa and having this opportunity to meet with this great community. I also wanted to thank Administrator Nelson for demonstrating the commitment that NASA has to seeing the utilization of the International Space Station not only continue at its incredible pace of innovation and discovery, but enabling new pathways and access to space in partnership with other government agencies that address priorities to the nation in addressing health issues and value creation in space. I also wanted to acknowledge that with sincere gratitude the participation of this community today as we sit underneath the dining room at Hogwarts. It's truly an honor and an unexpected pleasure of my career to be here with you today. So to address the question that Esene asked, we have learned over the approaching 23 years of continuous human presence in space that the International Space Station is a tool unlike any other tool that we've ever created in the history of humanity and enabling not only scientific discovery and furthering our exploration goals, but more recently we've learned that having access to the space environment informs us and accelerates innovation and technology development, has direct impact here on Earth. So through the efforts of NASA and the participation of other government agencies with the creation of the International Space Station National Laboratory, we are able for the first time in humanity to leverage access to space to support research and technology development that truly enables us to exploit all the benefits of that absence of gravity in the space environment. So unlike any other force that I'm aware of, it's interesting that the absence of gravity, this microgravity environment, is a tremendous force multiplier. It enables us to utilize space to accelerate technological innovation that directly benefits not only NASA and its exploration goals, but the goals of the nation in addressing needs, dire consequences, grand challenges here on Earth. So we seek with the announcement of Igniting Innovation to continue to enable access to space for the community here and other communities of research investigators who can help address these national needs here on Earth by providing access to the space environment. We are very honored to be joined in this new solicitation by Dr. Carnell and members of Biological and Physical Sciences, continuing this long partnership across multiple agencies in NASA who not only see access to space as important, but actually on the critical pathway to success in each of their research portfolios.
Thank you, Mike. Now, Lisa, Biological and Physical Sciences is also actively involved in microgravity research and addresses fundamental science questions across the broad spectrum of biological and physical sciences. So can you please tell us about the BPS research portfolio?
Sure. Thank you for that question. And I just wanted to circle back to a comment that Mike made about Administrator Nelson's comments. It was incredibly heartwarming when we had a meeting with him a few weeks back, and he demonstrated his incredible passion for the science and the research that we're doing on the space station. And he was more than enthusiastic to participate. And since he couldn't be here in person, he offered to share it through video. So we're really honored that he is demonstrating such a complete commitment to all of the research that's being conducted on the space station. So as far as BPS, which stands for Biological and Physical Sciences Division, we've been doing research in the spaceflight environment for decades, back through the shuttle era. So we lead the world. Our mission is to lead the world in fundamental space-based research. So, and once we learn that fundamental aspects, we hand that over to those for the translational benefits. And through that, we pioneer translational discoveries, we enable exploration, and all of that benefits life here on Earth and for our crew in space. So the Biological and Physical Sciences portfolio is incredible. It's very diverse. We touch on everything. In the biology area, we touch on plants, microbiology, and all different sorts of model organisms. And our physical sciences are incredible. They range from quantum, combustion, materials, and you name it, we are doing it in materials and soft matter. We also have, we're working in translational benefits with other government agencies. We have so many areas that we're touching on in both physical and biological sciences. And all of that we're doing that will hopefully eventually translate to benefit here on Earth and space. We are very science community driven, and so we'll be setting our goals based on the decadal survey that is due out around the end of August timeframe, and that will set our goals and trajectory for the next 10 years. So it's a really exciting time for the division, and we look forward to sharing that with the community. So, please pay attention and look for the outcomes from that in the next several months.
Thanks, Lisa. So even though your organizations have slightly different missions and sponsor different experiments on station, I understand that both your organizations work together on research that benefit not only human crew on long-term deep space missions, but also benefits humans on Earth. Can you both tell us about that? Lisa, do you want to start?
Yeah, sure. Do you want me to go ahead and start with
Yes.
that? I would love to. So, just recently, I would say about 2 years ago, I was really fortunate to have partnered with several other government agencies, and I think you saw the list that Esne shared there. It was incredible. So there is this really interesting technology that is a model system. Mike can tell you about it a bit more too, that they've been working with that up on station. It's called tissue chips, organ-on-chips, organoid models. These are really advanced in vitro models that mimic the biology of the human in a really small device so that we can make these tissue chips and organ chip models and recapitulate the human body and then expose that to different spaceflight stressors and get a much better understanding of what's happening to the human. Well, from that, we built additional partnerships with other government agencies for health and medical benefit here on Earth. So when we partnered with them, one of the goals that we all came together on was how can we take advantage of these new innovative tissue chip, organ chip platforms and apply them for all of our needs, because they were pretty new, early stage, and they didn't live beyond like 2 weeks, some of them a month. And so one of our pushes was, well, we'd like to have these extended to a minimum of at least 6 months. Obviously, we'd like a year or longer. I could envision sending these on deep space exploration missions to better understand, healthcare and spaceflight effects for the crew. So we partnered with the National Institutes of Health. We partnered with several institutes within that, the National Cancer Institute, Institutes of Allergy Infectious Disease, the Center for Advancing Translational Sciences. And through that, we all awarded nearly $20 million in research to extend the longevity of these platforms to 6 months or more. And so we are very committed to advancing science for benefit here on Earth and in space, and the translation of this knowledge will benefit NASA to use these in spaceflight environments, and our partner agencies on the ground can use these to look at health effects, longer term effects. If you're thinking COVID, long COVID, or toxicity effects from chemical exposure or drugs that are, and the efficacy of those. So it's an incredible time right now for this.
Thank you.
And I'll pick up on that. We too have had a long relationship, not only with different programs within the agency of NASA that support R&D activities and sponsor research on station, but have also followed the mandate of the creation of the ISS National Lab to reach out beyond the confines of NASA to establish partnerships with a list of other U.S. government agencies that have had or hadn't realized they had the opportunity to have access to space to further their own goals. So we too have partnered with the NIH. We initiated a conversation with the National Center for Advancing Translational Science, NCATS, that Lisa mentioned back in 2016 to foster the first opportunity for tissue chips technology to go to space. At the time that we did that, we understood, as well as our partners at NIH understood, that this technology is on the critical path to the future of improving biomedical outcomes here on Earth. And very recently, I'm sure this audience is aware, FDA has furthered that move towards divorcing ourselves from reliance upon the use of animal models in drug testing. We understand that it is the current state of the art and it's necessary, and that it does provide valuable data, but you have to do a lot of work and expend a lot of resources, including human capital and finances, to get through from preclinical to clinical trials using those animal-based models. So with the onset and progression of technology supporting the development of these tissue chips, we were able to offer access to their development in the space environment because, as Lisa mentioned, we understand that the exposure of these human avatars, these organ avatars in space, the nation benefits because you have access to an accelerated onset and progression of symptoms due to exposure to the microgravity environment that mimic many of the things that happen to us here naturally on Earth, in which NASA, through the Human Research Program, has worked to combat in space for years and years. So many of the things, all of the things actually that happen to human crew with prolonged exposure to space are replicated in some way in these small avatars of the human body. So this is a new development in that we are leveraging space not only to further NASA's exploration goals, but actually accelerate the pace of innovation and discovery. This also led NIH, NCAT specifically, and some of the partner agencies and centers at the NIH to think about ways that design principles could be influenced here. So as we moved through that partnership with NCAT's called Tissue Chips in Space, NIH began to realize that a lot of the things that derive engineering design and experiment design to support the use of these tissue chips in space were enablers for improving the technology here on Earth. So the things that the community of payload developers in this audience think about, mass, power, and volume, lend themselves also to benefits in the reproducibility, quality control, and higher throughput for these tissue chips on Earth. So designing the experiments for space actually has led to innovation and new investment opportunities, new support from NIH and other agencies, and furthering the development of these tissue chips to replace animal models in the future. So it's an example of multiple agencies and institutes working together to leverage that force multiplier which microgravity has been. It also enabled us to further follow up on the development of space as not only a test bed facility, but the International Space Station as a test kitchen. So there was a lot of risk involved from the principal investigator community and the payload developer community in developing these systems, but it in part led to new opportunities through biological and physical sciences to partner with those agencies to address a technology gap in the utilization of these chips, which was their longevity. So the results of that work, I think will go to space very soon as well and offer even better opportunities for those types of technologies to be further utilized in space. And I wanted to mention too, we've had going on 8 years of participation from the National Science Foundation as well. So at the more fundamental end of the spectrum, we've worked to build partnerships with the National Science Foundation to further their interest in prior partnerships with NASA in utilizing microgravity to advance different programs of interest to the National Science Foundation. One of those being in the area of tissue engineering and mechanobiology. So we are working at multiple points in that research spectrum, from fundamental scientific discovery through to use-inspired application, and more recently now through the development of the In-Space Production Applications Program in partnership with NASA, focused on value creation and understanding ways to help bridge that valley of death from fundamental scientific discovery to preclinical use, clinical application, and/or the manufacturing or improvement in processes and manufacturing that are of interest to the commercial market.
Thanks, Mike. Now, Administrator Nelson made a mention about a research announcement about something called Igniting Innovation. Now, I'm very curious, and I'm sure the audience is as well, so can you end the suspense for us, Mike?
If I say no, will you throw me off stage? No, slander. So, no, thank you, Ezinne. Yeah, again, as I mentioned at the onset here, I am honored to be joined here today by Ezinne, who played a part in this, although she's probably not aware of it, in working with the Office of Science and Technology Policy and helping to put forward the administration and prior administration's vision to enable renewed government investment to address critical challenges, medical challenges here on Earth. We sought at NASA and at ISS National Lab to engage access to the International Space Station as a way to further those goals, with specific focus on the cancer moonshot. So we have been able to utilize the research environment in space, as we mentioned, for a long time, that furthers our goals here, because some of the manifestations of tissue growth in that space environment not only enable accelerated models of many human diseases here on Earth, including some cancers, they also enable test facilities, test beds, avatars that can accelerate the therapeutic treatment of those diseases by enabling more rapid discovery of effective therapeutics as you move through that progression. So we are happy to be able to share with you today that in one short week, on August 8th, the release of the Igniting Innovation National Lab Research announcement will go live on our website. Through that opportunity, we are going to offer a unique opportunity to the community of researchers in the United States to seek access to the International Space Station National Laboratory in collaboration with Biological and Physical Sciences to propose a series of flight experiments that enable you to achieve a new end state which directly addresses unique challenges here on Earth, specifically addressing those in the area of regenerative medicine, tissue engineering, and the discovery of new therapeutics, new biomedical diagnostics, or other aspects of tissue chips in space and stem cell expansion that can speak to the cure of diseases here on Earth. So it's a different sort of national lab research announcement that we've had in the past, in that this one affords the community the opportunity to identify multiple flight opportunities, which gives you as the community the opportunity to identify the number of flights that you need in order to achieve your desired end state, so that we can help accelerate the pace of discovery and innovation here on Earth. This also coincides quite coincidentally, unfortunately, with new efforts from ARPA-H and the creation of ARPA-H as a derivative model of DARPA to address health outcomes here on Earth and accelerate that pace of discovery. So there's a recent broad agency announcement from ARPA focused on osteoarthritis and models. And we're confident that what we're able to offer with the Igniting Innovation Challenge will also offer some opportunities for ARPA's efforts to accelerate the pace of innovation for biomedical outcomes here on Earth as well.
Thank you, Mike. What a fantastic example of continuity, and a policy gets implemented and executed down the road. So thank you for that. Now, Lisa, I understand that biological and physical sciences also has some exciting news to share.
Well, our news to share is that we're really excited to be partnering with the ISS National Lab, and Mike Roberts and his team. You know, we're no strangers to each other. We've been working together for years, but this is the very first time that we've actually had a collaborative solicitation. And we're so incredibly excited with this opportunity to, you know, put something forth with commitments from both of us to look at how we can employ some of these advanced in vitro models to address some of these diseases here on Earth and study these effects that, you know, sometimes you can't see the things that you can see and do in space flight, and what it enables is incredible, and you can't do that here on Earth. And so being able to look at cancer in a different way, as Mike was saying, or some of these other age-associated diseases that, you know, are also problems for our crew when they return, muscle atrophy, you know, bone loss. So this is an incredible opportunity, igniting this innovation for both of our organizations to tackle some of these really critical problems for Earth-based medicine and to help NASA and its crew for some of these sustainable presence and long-duration missions. And then speaking to ARPA-H, we've been discussing that too, so we're really excited that there will be some future opportunities in that area as well.
It sounds like an amazing opportunity for researchers. When can the community expect this solicitation to be on the street?
August 8th is the release date. We'll have an opportunity to brief the payload developer community who heard a little bit about this yesterday, and it's dark up here. I can't see if they're surprised to be hearing this again. But we'll have an opportunity to share with the payload developer community some of the nuance about the difference of this approach. And part of it will be that we are asking the research community and the payload developer community to include as part of this application process a roadmap. We seek to have real-world outcomes, and we want to be able to better align and optimize access to resources for launch services and access to crew time on the International Space Station, so that we continue to enhance access to space and this really achieve the decade of results that we're currently in. So there will be a formal release in 1 week on August 8th on our website. We'll also release a couple of webinars in addition to information from this conference that provide more detail about the solicitations, and will provide an opportunity for the communities of researchers who seek access to the International Space Station to ask questions about how to apply to this and make the best possible use of this new opportunity in space. We do not intend for this to be a one-off. We seek to continue to build new relationships across research and technology development programs at NASA, and just as importantly, to expand the universe of U.S. government agencies that are providing funding to the research community to utilize the International Space Station and help bridge the transition period as we move into commercial LEO destinations in space to not only replace the International Space Station, but greatly enhance the services and capabilities that we as a nation and our international partners have in the space environment.
Thank you. Now, you mentioned all the information would be on your website. For those paying attention right now and taking notes, can you repeat your web address?
Yes. So if there's anybody in the audience who doesn't know how to find us, shame on you. We are at issnationallab.org. We will also be, I think, announcing this through Inspires as well in partnership with BPS. So you will be spammed if you're subscribe to either Inspires on the NASA side or through the ISS National Lab website. We understand that there are some differences in the formulation of this new National Lab research announcement and our partnership with Biological Physical Sciences. So we encourage the community to continue to be inquisitive and to ask questions about it. And again, we don't view this as the end state. This is just, I think, a continuing step on the journey to further enhancement of access to space and augmenting its ability to really, really benefit Earth by accelerating the pace of innovation and discovery, the reason that we're here this week.
But this has been a great conversation. Many thanks to Dr. Lisa Carnell. Many thanks to Dr. Mike Roberts. And thank you all for being here with us and to receive their exciting announcements. And many thanks also for all the work that both of you do with your organizations.